Um, yeah, I was trying to measure, this circuit I built, spec agnostic circuit. With my scope, and I was trying to probe across the inductor, and I was like, well, what the fuck, it keeps killing the signal, it would kill the signal in the analog discovery every time I did it. Finally realized the damn scope probe must be grounded, and this circuit must be grounded somewhere. So it's either coming from the analog discovery or that power supply or something. Power supplies are supposed to have that center ground terminal. They're not supposed to be grounded in general, but I have seen ones that were, but still I haven't determined if that's true or not with that. Analog discovery could very well be grounded, especially with that module on it, because again, it still is connected to the PC. The PC's chassis ground or whatnot, I believe, comes through that USB cable, that metal sheath part of it. I think that's linked to the chassis. And if it is, and they linked it to this somehow, then, well, that could be where the ground is. I don't know. I haven't tracked that down yet, but just to eliminate the problem, I don't know if you can see it or not, but see, I got one of these little, those little gray things that you use as to adapt 3-prong to 2-prong outlets. You just stick that in there, and that basically cuts the ground isolation. So now, because it wasn't mattering, if I took the probe, loose from that, basically the signal wouldn't change on the scope at all. So that tells you that, you could barely see any difference. But now, this is what happens when I take it loose. It still picks up the signal, but not, it's not stable anymore. And if I, connect it back to the ground point, well, then it is. And, of course, that stabilizes my signal, because my signal over here was completely disappearing before when I took the scope across the inductor. And I don't have it across the inductor yet, but it was completely vanishing before. So yeah, that's what gave me a hint. I was like, why the fuck would even a 10x, why did a oscilloscope probe, kill my signal? That doesn't make sense. But yeah, it's, kind of a ground issue. And like I said, that's the signal it looks like from ground to the midpoint of this inductor. See, this capacitor and this inductor are, essentially making kind of a series resonant circuit. So I just wanted to look at the voltage across it out of curiosity. It's a low Q coil. It's not going to be anything too exciting, but let's see if I, that's the signal we got now. But if I take it, and remember, that's analog discovery now, so if I take it, because it still has a bizarre effect, if I take it and put it across the coil, alright, now we're seeing this kind of signal. So that's, what you might see in a resonant circuit. It's measuring, about 2.6 volts peak to peak, but you can see my signal's got some damn jitter in it because of doing that. Still not sure why that is. I have a feeling it has something to do with spurious noise maybe being fed through on this ground line, because it's still a low impedance to the scope in general. So again, you might be better off still with a differential probe, even a cheap one that you build. Like I saw a video on the internet on how to build a cheap differential scope probe with a 324 op amp as an IA. It might be good enough for low frequency stuff. To might build one at some point. But what's great about this method, of course, like I said, with that little that little gray adapter, you can always just remove it, if you want to hook it back up to scope ground. Because again, there may be times when you do want it that way. Even this, I'm still not convinced it's the best configuration. But other times that you may want that ground connection just for reference, and it might make the scope quieter. I'm not really sure. It seems like it wouldn't, but maybe it does. I don't know. Not for sure. But you can go either way, because another option is, of course, you could just break the third ground prong off, right? Which is what I traditionally do, but there may be times when you want it. And not just for safety. I mean, again, I know what I'm doing enough to where I don't think that's going to be an issue. But at the very least, it may have some uses, so it's good to have that versatility. But at any rate, yeah, I just, thought that was bizarre, a little unexpected. I'm still confused, but I have a feeling this is noise writing on top of the signal, just like you see if I disconnect it's picking up. Ah, shit. I hate cheapy ass clips. But you see that jumping around like there. I mean, I have a feeling that's induced noise, maybe from line hum or something that's not being dealt with properly. Because of course it wasn't doing that before, but then again, it was linked to earth ground, so of course it wouldn't do it, given the fact this circuit appears to be linked to ground. So anyway, just a little investigation there out of curiosity. Leave your observations in the comments below. I wanted to add a couple little comments about this grounding scheme. Now, generally speaking, you should always, when you're defeating a safety ground, always be cautious, especially with something like an oscilloscope. And the reason is that, basically this normally is attached to earth ground, right? Well, you touch this every time you're like changing your probes or something, right? So let's say you are probing some kind of 110 volt circuit, right? And you defeated the ground on it. Well, you may have the leads completely reversed. This terminal could actually be tied to hot, either hot or near hot or something like that. If you're probing a 110 volt circuit or even a 70 volt, let's say you're looking at a stereo amplifier or something. Of course, I don't know that having a grounded oscilloscope would help you there, because a lot of times sometimes those things are floating. But there are circumstances where let's say you got an auto transformer that's 70 volts or something, and it's hooked up backwards or some shit, or not, but it's still ground referenced even on the secondary. Well, you could be grabbing this to change the probes and get the shit shocked out of you. Because this could inadvertently be hooked to 110 volt ground. So you want to watch doing this. But boy, there are times this gets annoying, because with that same caveat, sometimes you can destroy your circuits by hooking it up to it. Not remembering that your scope is grounded or your equipment is grounded. So I mean, it is better to have it connected there. So my advice is generally leave this unconnected, connected to ground like it's supposed to be, and then if it's really becoming a problem, temporarily switch it over. In fact, that's the neat thing about these do have little tabs on it, so you could make a little jumper wire or something and connect it to another ground point, so it's more convenient. But the point is that do things like that with caution, because if you are probing some circuitry that is exposed to mains power, it can get you in trouble. But boy, there's a lot of times this becomes a problem. But again, really the best solution, like I said, is to really get some kind of differential probe. Like I said, you can make some cheap ones, for like $5 or something, which will kind of give you some of those same benefits, although they're not isolated. But they at least give you some of that same benefit, that you don't have a low impedance ground, versus a high impedance signal line here. So they become differential, because it's basically an instrumentation amplifier that guy built. But it does limit, there's certain, voltage constraints and stuff like that you got to look at. But I mean, the point is that, do this with caution. And don't just go thinking it's okay to do that. And it's because normally I would say, because I honestly have usually take needle nose pliers, and I've ripped it off about that third prong off the quartz off about 30 or 40% of the shit I've ever bought, just because it won't fit in an extension cord or something like that. So I mean, normally it's not really that big of a deal. I mean, you shouldn't do it, but normally it's not that big of a deal for like shop lights or something like that. But again, better to have it, but if you know what you're doing, you can kind of get around it without killing yourself. I didn't kill myself after all these years doing that, but having said that, it's still better to at least have a clue what you're doing before you do it. But But with something like this, since you are actually making contact to what is in fact grounded, that could become a problem, because that is part of your actual test signal. So again, that's why doing it here, you do it with caution. But definitely, if it's causing a problem like it was on this circuit, with me being able to probe it properly, yeah, I mean, that's, it's nice to be able to defeat that every now and then when you need it. So anyway, I just wanted to point that out, a little bit of caution. But so there you have it. Cheers. Yeah, in addition, I wanted to say that, when I was younger, I actually was dealing with a 24-volt auto transformer that I had hooked to a lamp cord, and of course, it got plugged in the reverse, so, I didn't know I was working on a circuit that actually had high voltage, line voltage, hooked to it, basically, and, so I went to solder a wire onto it, and the sparks really flew, I'll tell you that much. I had no idea, but yeah, I blew out a couple of SCRs I had on the circuit, or triacs actually I had on the circuit, I guess. But at any rate, if you did the same thing with scope probes, you had your, if I'd had a scope probe hooked to it at the time, and went to insert one of the probes, to remove it, put alligator clip probes on it or something, well, yeah, I would have gotten a nasty shock from that terminal in that event if I'd had the ground terminal of the scope hooked to the ground terminal of the scope. Of course, it would have, thrown sparks and probably damaged my oscilloscope. So my point is that, safety ground, can do things, but it could also damage your equipment too. So, there are circumstances though when, you might not know it. So, even, with that circuit, depending on where it's probed, I still could have gotten a nasty shock unexpectedly, even if it didn't damage my scope due to a resistor or something, in line with the probe. So, you still could have gotten a good shock out of it. So, anyway, just wanted to point that out. That's what I did when I was younger. So, anyway, cheers.